Hello class, and welcome to the next video, graphing linear systems. And we're going to cover two things today, graphing linear equation systems and linear inequality systems. And for those of you again in boot camp, this will be really familiar and hopefully a little easier. It sounds very different, systems, but it's really only one more step in the process. So if you think about the word systems, what it means is things working together. And that's what's going to happen here. They've got two lines that that tell you where the solution is. Kind of just like how GPS satellites tell you where you are. Linear systems go from having an infinite number of solutions, like every point on the line, to having usually just one solution, which is where they cross. So if these roads were a linear system, this would be the solution right here where they cross. Okay, so let's take a look at some examples here. I'm going to make both of those things disappear and put a graph on the screen and put up our first systems question. So if you notice, there are two equations now rather than just one. The first one is in the form that we want, y equals x plus 1, and I'm going to kind of just make a line down the center here. And you'll probably want to do that too. Now, y plus 3 equals 2x, that is not in the right form. So the first thing we need to do is solve for y, and it only involves one step. So we get y equals 2x minus 3. Now obviously some of the ones we'll do later are a little bit more difficult to solve for y, but we didn't want to focus on that today. We still want to write our m and b for both of these. In this case, our m is 1, our slope is 1, and I like to leave it as a fraction, 1 over 1. And b, or the y-intercept, I'm going to write b again, is 1. So let's graph this one first. This one starts here at 1 and goes up 1, right 1. So it looks like that's a pretty simple, straightforward line. Okay. Now before I actually draw the line here, I want to see where they're going to cross, because I don't want to stick an arrow, let's say right here, and then actually they cross right there, and it just makes it messy. So I'm going to get rid of that. And what I really should be doing is in a different color making the next one. So let me do this in blue here. I'll just go over this in blue. So my slope for this one is 2. But I like it as a fraction, 2 over 1, and b is the negative 3. And make it all blue. So I'm going to start this one at 1, 2, 3 below negative 3 there, and then it goes up 2, right 1, up 2, right 1. So it looks like it's going to cross somewhere up here, right there. And sometimes I just go ahead and circle where it's going to cross. And I'm going to pause the video and make the line so you don't have to watch me play with the line tool and not know how to do anything. Okay, so I got my two lines in there. And I can see that they, in fact, cross at this spot. And we label that spot. It's really important. This is different in systems that we label that spot. I don't really like that color. Oh, a nice, lovely brown. And we're going to label it. This is at 1, 2, 3, 4 is the x value. And then 1, 2, 3, 4, 5 is the y value. So it's the point 4, 5. I really need to label my lines now because there's two of them. And on the regions, usually you can get away with not labeling your line if it's one line, but we don't risk it. And you can get away with forgetting to label one of your two lines, so that way they know you know which one you're talking about. But you definitely lose a point if you forget both lines. But we're going to label everything every time anyways. And that line tool didn't put arrows on, so you do need arrows as well. Alright, so technically we visually answered it, but we still need to do the check, because the check's going to tell us if we really did it right or not. So we're going to say check the point 4, 5. And you go back to the original equations they gave you. So not the y equals form if you turned it into that. And then then 5 for y, and 4 for x. And you can see this one, the checks are really easy most of the time. That one comes out right. And this one's 5 plus 3 equals 2 times 4. So I'm just replacing my y and my x with the 5 and the 4. And that is 8 equals 8. So as long as they both work, that means that this point right here is really on both of those lines. And if you ever get a check that works on one of them and not the other, it's no good. That just means you picked a point on one of the lines that it worked on, but it's not on the other line at all. So you have to go back and figure out what you might have done. Usually that means that the line that it worked out on, that one was graphed correctly, but maybe the other one was not. Alright, moving right along, this time we have inequalities. And there's some differences here too. So we're going to start the same exact way. We're going to, well, I'm going to pick a new color, orange this time. And we're going to say this is not solved for y, so we're going to add 4 to both sides. And I get y is less than x plus 4. That's one of them. And then the other one, I got to do two things here. I got to add 6 to both sides. So I get 3y is greater than or equal to x plus 6, and then I can divide everything by 3. So that's a y is greater than or equal to 1/3 x. Because remember, there's a little 1 right here, and that has to divide with the 3. Plus 6 divided by 3, which is 2. So here my m is 1, and my b is 4. And I'm supposed to be using, oh, I keep clicking my undo button, so if you see things disappear all of a sudden, that's why. M equals 1/3, b equals 2. Alright, so I'm going to, let's say the green for this one, I'll just put a green star on it. We're going to start at 4. 1, 2, 3, 4. We'll always start on the y-axis. And then the slope is up 1, right 1. So it has the same slope as that one before it. Now I'm already thinking ahead here. Is this going to be a solid line? Is this going to be a dotted line? And I look back right here, and this is a dotted line. So I can almost leave it like this. I'm just going to hand draw in a dotted line. Again, I might have, hopefully I went long enough. I broke my rule of waiting. And the next color, how about red? It's bright red here. And this one starts at 2. Goes up really slowly. Goes up 1/3. 1/3. And this is usually where I get kids saying, hey, these are never going to cross. Well, yeah, if you keep going to the right, they're never going to cross. But you can see that they're eventually going to hit on the left side. So I go, this is the only time you go the opposite way. Instead of up and right, I'm going to go down and left. And you can see as soon as you do that, you hit where they cross right there. And this one's going to be a solid line. I'm going to freehand this one because putting those lines in are kind of annoying actually. Oh yeah, that's beautiful. That's terrible. Alright, either way, you get the point. Now, we don't label the point where they cross because really that point is not one of the solution points. And do you know why? So that point is on this line, which is a part of the solution, but it's not on the green line, which is not a part of the solution. Well, excuse me, it is on the green line, but the green line is not a part of the solution. So we have to figure out where the solution is for this. And yes, you have to shade both parts here. Let's see, I have a cool tool for this. Alright, I got the cool tool. So I don't know if you can see the weird blurry cursor I have now, but in the first one, in that green line, it says y is less than x plus 4. So that is everything below the green line. So I'm going to shade it in. Oh, that's weird. It's supposed to be like a yellow, but I made it a little too light. Let me bump up the opacity here. So it's everything below the green line. Kind of just looks like I got the page dirty. Alright, then I look over at the red one. I'm going to make it blue this time. I was supposed to make green when you mix blue and yellow, but this yellow is so ugly. It's y is greater than or equal to the red line. So I want to go above the red line. So I'm going above the red line. And where it's double shaded, you can kind of see, we'll make a little black outline here. You can see where it's double shaded right here. And we label that with an S. S stands for solution, and it's any point within these parameters is in the solution. So let's pick one. Maybe one right here. And that point is 1, 2, 3. 3, and then 1, 2, 3, 4, 5. 3, 5. And we're going to check that. So we say check 0.35. And again, the originals here. I got to try to squeeze this in. Y minus 4 is less than x. We plug in 5 minus 4 is less than 3. 1 is less than 3. Check. We know that works. But it has to work in both. So let's see. 3y minus 6 is greater than or equal to x. 3 times 5 minus 6 is greater than, what did I say? Yep, 3. This is 15 minus 6, which is 9, which is greater than 3. So again, it works. So I know that the 0.35 is in the solution. Doesn't mean I did everything perfectly, but I probably did. So that is how you do a inequalities system. So just to sum it up, you still solve for y. You still graph in the exact same way. You just do 2 of them. If it's an equation, you just see where they meet, and that is the one point that's the solution. If it's an inequality, it's where you've shaded twice. If you need to, go back and just rewrite what I just said there and make yourself a little step 1, step 2. I could write it for you, but then I'm doing it and not you. So I want you to do that. Go back and listen if you have to. Write down all those steps. And then we'll practice this a bunch more in class. All right? Have a good night.